Okay, today we're going to be talking about section 6.6. Section 6.6 is talking about functions and talking about the domain of the functions and basically adding, subtracting, multiplying, and dividing those functions. So, all you basically have is you're adding two functions together. You're just going to take the f plus the g. This one, when you're subtracting making sure that you are distributing that negative into the g. Then f times g and f divided by g. G cannot be 0. G cannot be 0. Super important there. So we're going to go right into some rules for the domain. Domain is all the values that x can take on, making the expression true or the equation true. Now, rules that you need to know. If I'm taking the square root of something, an even root, the square root, the fourth root, the sixth root, I know that the stuff underneath the radical has to be positive, meaning it has to be greater than or equal to 0. The stuff under the radicand itself, the junk, has to be greater than or equal to 0. If it is not, then that puts me in the imaginary number system and I'm not allowed to do that. Now, fractions are also our other issue. Fractions with a variable in the denominator, you're going to set the denominator not equal to 0, and that's your domain restrictions. Now, we learned notation previously. We learned about set notation. Set notation is going to be x is an element of the reals. The line is such that it's greater than or equal to a number. The interval for it is going to be bracket the number to infinity parenthesis. We talked about this before. This is the symbol for an element or a member of, and this is the real number system. We just do a boldface R, okay? So let's jump right into this. Let's talk about the domain. How do I do the domain of this? I'm going to take the junk underneath, which is x plus 4, and that must be greater than or equal to 0. Why? Because if it is negative, I can't do it. So that means x is greater than or equal to 4. So how do I write this? X is an element of the reals such that x is greater than or equal to -4. And that is fine. Okay? If I'd have interval notation, I'd have -4 to infinity. Okay? This one right here, 2x, the square root of 2x minus 5, I only care about the 2x part. So that means 2x must be greater than or equal to 0, so x is greater than or equal to 0. So how do I write that? X is an element of the reals such that x must be greater than or equal to 0. Okay? Now, the cube root is different. Remember I said before you could take the cube root of -8 and it gives you -2, so therefore there are no restrictions whatsoever here. So if there are no restrictions, that means x can be any real number that it wants to be. Over here, I talked about if you have a variable in the denominator you can never divide by 0. So what this means is you're simply taking the junk in the denominator and saying that denominator cannot be 0. So x cannot be -2. So I'm saying I'm putting it in its number family, meaning it can be any real number, but x can't be -2. Okay? Same thing with this one right here. The denominator, don't care about the numerator, I care about the denominator. So the 3x plus 2 cannot be 0. So 3x cannot be -2, so x cannot be -2/3. What does this mean for my answer? X is an element of the reals, and x cannot be -2/3. Okay? So that's domain. So we talked about domain, and we've talked about what we have to do to find the domain. Now let's go ahead and actually blend these two functions together by either adding, subtracting, multiplying, or dividing. So I give you two functions. Here's f, and here's g. I want you to go ahead and add those two functions together. So if I'm going to add these two functions together, I'm going to take f of x plus g of x. So f of x is 4x plus 7. G of x is the square root of x plus x. Combine your like terms. 5x plus 7 plus the square root of x. That is f plus g. Now, the question is what is the domain? Well, the domain says that this right here cannot be. It absolutely cannot be negative. So therefore, x is an element of the reals, and x must be greater than or equal to 0. You can use a bar or a comma. Okay? Same exact problem, but this time we're going to do subtraction. So if I'm doing subtraction, I'm going to take f of x minus g of x. F of x is 4x plus 7, putting in parentheses, minus g of x, which is the square root of x plus x. Now, drop the parentheses around the f and distribute. Combine like terms, 3x plus 7 minus the square root of x. Same exact domain, x is an element of the reals, and this x has to be greater than or equal to 0 because I cannot take the square root of a negative number. So I've done adding and I've done subtracting. So what's next? What's next is two new functions. And now we're going to multiply and divide. So I'm going to take f times g of x. So my f function is x squared minus 9. My g function is going to be x plus 3. Your goal is to FOIL. X squared times x is x cubed. This is going to be plus 3x squared minus 9x minus 27. There are no like terms there. Now all you have to do is say, do I have an even root? Not an even power, an even root. I do not have any square roots in there anywhere, and I do not have any fractions anywhere. So guess what? I have no restrictions, so therefore x is an element of the reals. Same concept, same two functions. Here's my two functions. I need to go ahead and this time do f divided by g of x. My f function is x squared minus 9. My g function is x plus 3. Do not reduce yet. I want you to do the domain first, then do your simplification. So my domain says that the x plus 3, that's in the denominator, it cannot be 0. So x cannot be negative 3. So therefore, x is an element of the reals, and x must be greater than or equal to, I'm sorry, I said that wrong. X cannot equal negative 3. From there, you are now going to reduce. How do I mean? Factor the numerator. Factors of 9 are 3 and 3, plus and minus, and then x plus 3. Now, the x plus 3's cancel out, and my reduced f divided by g is x minus 3. Okay? Next, same concept. I give you two new ones, and we're going to do f times g. So that's going to be 3x squared minus 11x minus 4 times 3x plus 1. So 3x squared times 3x is going to be a 9x cubed plus a 3x squared. Then I'm going to do the next one. This is going to be minus 33x squared minus 11x. Did you see how I put the like term underneath of it? And now I'm going to do the last term, which is going to be negative 12x minus a 4. And I'm simply going to drop down and add the like terms together. Negative 33 and 3 is going to give you negative 30x squared minus 23x minus a 4. That is how you FOIL a trinomial times a binomial. Okay? So your answer to that is going to be 9x cubed minus 30x squared minus 23x minus 4. Domain. The domain of that function is going to be x is an element of the reals, but I don't have any fractions. I don't have any even roots, so therefore there are no restrictions. Same exact thing. Now we're going to do f divided by g of x. My f is 3x squared minus 11x minus a 4 all over 3x plus 1. Just like the previous two examples previous ago, we are not going to simplify, but we are going to do the domain next. 3x plus 1 cannot be 0. So 3x cannot be negative 1, so x cannot be negative 1/3. So my domain is x is an element of the real, but x cannot be negative 1/3. Okay? From here, we are going to go ahead and factor. So this is a 3x and an x. I need to get a 4. Factors of 4 are 1 and 4, or 2 and 2. I'm going to use 4 and 1. I'm going to put the 4 clear out there to get a 12. and this is going to be a plus, and this is going to be a 3x plus 1. Then these cancel out, and my final reduced answer is going to be x minus 4. Okay? That is going to be how you do that. We already got the domain, and we already simplified it, so we are done. Tonight's homework is 6-6, worksheet 1, function operations and domain.